Sounds good. Thank you, Eric. Thanks for having me, and appreciate the opportunity to talk to everybody this afternoon. I'm going to talk about diversion structures and my role with Trout Unlimited. I'm based up here in the Upper Gunnison Basin, but a lot of the work I do is related to diversions and trying to find funding for landowners to upgrade their ability to divert water from the stream into ditches for irrigation uses. So I'll talk about that just briefly, talk about different types of structures and talk about common issues that folks that I often see and folks are often dealing with, and provide some examples of design that seem to be effective up here. So with that, I'll try to figure out the clicker here. So yeah, what is a diversion? This is what I'm going to talk about real quick. Just challenges that people often face, considerations for design, and variations used up here. And I'll use a lot of photos. So there's the first couple slides have some text, but I got a lot of photos because I think it's easier just to point it out than to try to describe it, because there's a lot going on. So diversions, a real general description is just it's used to divert all or a portion of the stream into an irrigation ditch or another conveyance mechanism for just put it to beneficial use, put the water to beneficial use. And in general, what happens is you're trying to raise the head or the stream water elevation so it can enter that ditch and gravity flow down the conveyance structure. These common challenges, when you do, I'm going to refer off, to dams essentially, because that's what's used up here quite a bit. And whether it be a wing dam or a full channel structure or rocks, when you do place something in the stream, you got a range of flows. Streams naturally move material, debris, bed material, and it can deposit upstream of your diversion. When you get deposition upstream, like I'm going to see if there's a laser. Is the middle button? Top one's a laser. So, for example, here's some deposition right here. Similar here, that's the same structure. Here's another one where we're getting, you can see these trees that have moved down, and right up here is actually the diversion. You get the deposition, it decides that it's going to take the path of least resistance, and it's washed around the diversion structure. So now I'll show another photo of this one in a couple slides here, where you're sitting, the head gate's high and dry, and you can't get water into the ditch. I'm going to jump in, or I'll just bounce to the next one. And the other issue that I think is real common, depending on how the position of the head gate is with the channel, is just getting debris, whether it be trees, branches, leaves, etc., that can seal up your actual head gate. And it's regular maintenance to get out there and remove those. So there's some strategies to deal with that, more so with fine sediments. Trees and stuff are always going to be challenging. The other common challenge is when you're raising up the water elevation, right, and then it's got to fall back down to its natural level, and that creates velocity, which creates can create erosion. And a couple different types are, one, you can erode the banks. For example, on this one right here, you can see this is all that velocity is heading towards that opposing bank, and it's creating a big old open lake almost downstream. And what that does is over widens the channel, creates warmer temperatures, not great for trout habitat. And the other issue is here, once you have that, wide, when you're eroding this material from here, it's got to go downstream and essentially deposit somewhere, and that might create additional erosion. You get a mid-channel bar, for example, and the water wants to go around that and continue to erode banks. The other common issue is you have a deep scour hole. Here's an example of this. Right down here after this diversion, I've got a photo in the next slide of this diversion at high water. It's eroding downward, not laterally. It's making a big scour hole down underneath. So this one's like 12 feet deep, and what's happening is here's the ditch, and this bank is caving in. So the ditch is going to be compromised. So they're going to go in and do some riprap work here and try to fill in the scour hole with some hardened material so it doesn't keep eating down. And the here's another example. You can see downstream, like deposition. Here's the actual diversion. All this material is deposited upstream of it, and when it pours off, it's going around this direction and eating downward and leaving the head gate high and dry. During high flows, they have to tarp it to keep water out. During low flows, they can't get water into it. So these are the type of situations where we can try to find funding to put in a permanent rock structure, a new head gate that's operable, and better control for the irrigators. Here's some high flow examples. That's that same diversion here. You can see the amount of velocity and erosion capability that can occur eroding that bank. Here's an example of during low flows. For example, this is on the Gunnison River. They say 2018, really low flow period, they had to put additional rock out there to get water into their head gate, and then you get a high flow situation, and it creates some erosion on this bank over here, and it actually caused some blowout issues on this ditch just by choking down the channel and sending all that velocity towards the opposing bank. So there's a lot to deal with. There's all kinds of different varieties. I'll stress that every situation's different. It just takes kind of a operation by operation approach to really take into the consideration what's going on. The channel incision can result from one that scour where it's cutting down, and as it cuts down, you create a head cut moving upstream, and you end up with an incised channel, looking more like this. Again, so your head gate would end up being high and dry. Here's an example. This one, where's a push-up dam, they often would take this cobble here and with a backhoe push up material to get water into the ditch, and then they get high spring flows, and that material washes away, and because it's been disturbed, it's easier for that material to wash out and cut, incise the channel, essentially. Here's another example of that I showed earlier where there was a bunch of trees and that diversion was just slightly upstream. Here's the picture of the actual head gate looking upstream after that washout. So they're sitting about 1.5 feet, 2 feet higher than the stream channel. And I'll show some photos of an approach that may work for that situation on Ohio Creek. And again, on the main stem of the Gunnison, maybe the Taylor, the Lake Fork are some examples where you're going to have some recreational use, and there's challenges with that as well. Diversions can be designed that they're floater friendly, still raise the head elevation, and not have a dangerous either scour hole or trees or et cetera that are going to create a bad situation for somebody floating down the river. Here's the Whitewater Park. There is a diversion just upstream of the Whitewater Park that's also designed for kayakers, et cetera, the 75 ditch, and that's been pretty successful, I believe. And I know there's a couple others on the Gunnison that Parks and Wildlife has worked on, and the Upper Gunnison Conservancy District to try to make them functional for both irrigators and the recreational users. So here's some common designs that have been used. Again, it's site specific. You got to take into consideration what's going on, how the positioning of the head gate, location on the stream, size of the stream, etc. This has been used and seems to be pretty successful. This is the rock cross vein. It's like a classic Rosgan design. Step structure. If you got a lot of drop, you may have to do several grade controls downstream to keep that scour. Rather than just doing one straight pour over, it'll be a step down. These can provide some pretty good habitat, fish habitat wise, for late season, low flow periods, or even high flow periods as refuge in there. Here's an example is a push-up dam on Ohio Creek. Sorry to be so shaky here, but there's a vein there and a vein here, and here's the actual head gate when that was redone. And this is the head gate, and right here is a sluice gate, just kind of a rough sketch of what's going on in this situation. And the sluice gate can be operated to kind of keep some of the fine sediment from building up in your ditch. operate. You pull it open, say during high flow periods, and let that natural flow carry that sediment. Keep it moving through instead of depositing it right upstream. Then low flow, you can check that down and get it all into your ditch. And that can be placed, it can be placed down ditch somewhere at the head gate. It's site specific. And here's that one on Ohio that I was showing that was high and dry. And again, the water right owners were having issues with that diversion for years. TU worked with, is actually Sam and the Soil Conservation District to find some funding, local conservancy, Partners for Fish and Wildlife. We all found a pool of funding to put in a structure here. So this one, because it was how it was positioned on that corner of the stream and the amount of elevation needed to get water into the ditch, rather than doing a permanent rock structure, because we'd have to check it up about 4 feet, and just the amount of material and high flow events is going to want to try to jump outside the banks when you check it up that high. So we went with this kind of innovative design where it's actually a channel-wide gate. The concrete apron down here is roughened, so the fish can move through it when this isn't all the way down. They can move through, create some roughness, so it reduces that scour a little bit. Those boulders break up the velocities, and they drop this down when they say in the fall or late summer when flows really drop, and then they open it up completely during the spring and let that material flow through there. And here's another example from Tamichi Creek where low flow periods. This is not channel wide. It's actually sheet piling that's driven in. This is an NRCS project. The sheet piling driven in, and there's these little pegs. They flip up, and they can stack boards or panels across. And the same right here. When during low flow periods, they check it up and they send it into their ditch, or when they're done irrigating, they pull those out, and it's just all that is able just to flow straight through and not have the deposition upstream. I might have skipped over one slide back here that I was going to show you because there's another. Oops. Yep, here we go. Just real quick, there's another kind of effective, similar to how beavers work that's often used on Quartz Creek or Tamichi Creek. Here's the stacked logs. You have 2 buttresses, and then you stack logs across. Same in this situation, but during real low flows, you'd use a tarp to seal it up. But the challenge, this is the same diversion right here. The challenge this guy was having is to get those logs out was difficult. He had to take a backhoe and hang over and get a strap and yoink them out. So often the logs would just stay in there. So we designed a way that he's going to drop vertical panels in here so there's a little crank so he can manually pull them out as needed, so that's the channel's open during the periods when he doesn't need water. And that just reduces some of the erosion. He's having issues with it during high flows, jumping outside the banks and washing around. So that's kind of it. I'll field questions, and I'll just say, I'm always happy to just bounce around ideas. If you got site-specific things you want to look at, I'm always open to throw ideas out there and get some ideas on how to maybe fund some improvements. Gene?
Yeah. So what's the legal for a landowner if they need to do something on their creek? Do they got to get with an agency
For diversion structures, it's exempt. You don't need to get Army Corps permitting for the irrigation diversion structures. If you're doing, I think there's a distance. You can 200 feet comes to mind. I know you can move your irrigation diversion up to 200 feet for the Division of Water Resources, and that's still your point of diversion. If you go beyond that, then as far as the Division of Water Resources, you have to go outside. I think Army Corps is similar. There's a length of stream length that you can go outside from where the actual point of diversion that you can do work without permitting. Bank stabilization, habitat stuff. It's questionable if the bank's eroding an irrigation ditch. In some cases, you can be exempt for that, but generally Army Corps wants to see and get an idea of what you're going to do, and that's something I can help with as well. Or there's local consultants or NRCS can help get permitting to do some of that. Thank you.